So this is a quick teaching video on improper integration, which is the topic for this week. Hopefully we'll have some class time to talk about this, but if not, here we go. So improper integration. And this is anytime you have an integral where where in some way the infinity is involved. So like here's an example. -1 and 1 are no problems, but notice as I integrate from -1 to 1, there's a 0, it has to go through 0. And we know that 1 over 0 is a problem, right? Because if you think about what this graph looks like, you can see how that is a problem, because if we're trying to find the area under the curve, there's no ceiling in this little section right here. So what that means is that that means this is an improper integral, which means we have to handle it differently. So what we do is we break it into two integrals, and we say the first one is a limit from -1 to b, because b is the problem, or I'm sorry, we're going to break it from -1 to 0 of 1 over x dx plus the integral from 0 to 1 of 1 over x dx. So we can see the problem. 0 is the problem. So then what we're going to do is replace 0 with b. So we're going to rewrite this as the limit. No. We're going to rewrite this as the integral from -1 to b of 1 over x dx plus the integral from b to 1 of 1 over x dx. So in other words, we can't plug 0 in, so we're going to let b be something else, or just hold its place. And then we're going to put out here at the beginning the limit as b approaches 0. So we're going to let it approach 0 but not quite get there, and use the limit process to find out what it is. Okay? So then we go ahead and integrate this. Of course, the limit is still out here. B is approaching 0. The integral of 1 over x is ln x, and evaluated from -1 to b. And the integral of 1 over x is again ln x, and it's evaluated from b to 1. And then we're going to go ahead and plug all these numbers in, so that I still haven't taken the limit, so it's still the limit as b approaches 0 of ln of b minus ln of -1 plus ln of 1 minus ln of b. Now we got all kinds of problems here. First of all, we can't take the natural log of a negative number. Remember, when you ln it, when you integrate it with an ln, you got absolute value here, so that takes care of that, right? Absolute value, or natural log of 1 is 0, so this is going to be 0 and that's going to be 0, so we're left with the limit as b approaches 0 of the natural log of b plus, no, I'm sorry, minus the natural log of b. Now, as b approaches 0, what happens to natural log? So if you think about natural log, what the graph looks like is it looks something like this. So as we approach 0, what's happening to the natural log? Well, it's blowing up. It's headed towards infinity. So we'd say that this thing is divergent, which means we cannot evaluate it. Okay? So there's one example. Here's another example. So the same situation where natural log is when we plug in 0, that's a problem. So we can't really just do it normal. It's an improper integral. So our first step is to change this to the limit as b approaches 0 of the integral from b to 2 of the natural log of x dx. Then we have to integrate that thing. So remember, the way you integrate natural log is you let u equal ln x, which means du is 1 over x, and you let dv equal dx, which means v is equal to x. And so then this thing's going to be the limit as b approaches 0 of x ln x minus, and of course it'd be the integral of v du, which is just dx, so that's just going to be x. And that's evaluated from b to 2. So then we plug our numbers in, limit as b approaches 0 of 2 ln 2 minus 2 minus b ln b minus b. Okay? So what happens once again as b approaches 0? Well, this whole thing becomes 0 because of the b, and this approaches 0. So it looks like we're left with, excuse me, 2 ln 2 minus 2. So in this case, there is an answer. Let's do a couple more examples here. What if we have the limit of, let's see, from 0 to infinity of x over x squared plus 4 dx. With a squared on top. So here's another example. This time the infinity is in the limits, so that's clearly an improper integral. So the first thing we're going to do is rewrite this as the limit of, as b approaches infinity this time, from 0 to b, and this is x squared plus 4 squared dx. And this is going to be a u substitution, so I'm going to let u equal x squared plus 4. Du would be equal to 2x dx. So we'll rewrite that limit as b approaches infinity. The integral from, now when x is 0, that would make u 4. And when x is b, that would make u x squared plus b. So that way I don't have to switch back afterwards. Okay, so that would be u to the negative 2 du. And du brings in an extra 2, so we'll put a little 1/2 out there. Now we're going to integrate this thing, so that would be the limit as b approaches infinity of, let's see, that'd be u to the negative 1, and we'd need a negative 1/2 out front. And we're integrating from u, I'm sorry, that's a 4. From 4 to x squared. What am I doing there? I just totally messed that up. So that should have been b squared plus 4. There we go. So this is b squared plus 4. Okay. So we plug it in and we get the limit as b approaches infinity of negative 1/2 times b squared plus 4 to the negative 1 minus 1/2 negative, so that'd be plus 1/2, and that would be 4 squared, which is 16 plus 4 is 20 to the negative 1. Oh wait, what am I doing? No, this is just, man, I'm really messed this up. Sorry guys. I'm just plugging in 4 for u there. So that would be just 4 to the negative 1. Okay, so let's clean this up a little bit. The limit as b approaches infinity of, so that would really be negative 1 over 2 times b squared plus 4 plus 1 over 2 times 4 is 8. So as b approaches infinity, the bottom gets bigger and bigger and bigger, which means that the fraction is getting smaller, so that this goes to 0. So this is equal to 1/8. Okay, so there's some examples of improper integration, and so the key is to look at the limits and see if there's infinity in the limits, or if something in the limits or between the limits would make the equation go to infinity. So there you have it. There's some worksheets on Canvas that you can try this out.